All right, here we are on the back doing these problems. And let's just start with the first one. It's we're given this position function. Remember, this is basically s of t. Don't be confused with like speed or anything. It's s of t. It's the position function. We want to know when is the object moving to the right. If it's moving to the right, this means that the velocity will be greater than 0. So you need to find the velocity function, determine when it's greater than 0. So here's the velocity function is simply the derivative of this one, right? So the velocity function is going to be 3t squared minus 12t plus 12. And then I need to know, first of all, when is this 0? If I want to know when it's greater than 0, first I need to know when it is 0. So we set it equal to 0. And let's go ahead and divide everything by 3 as well, just to simplify our lives a little bit. And we get this, which factors into t minus 2 times t minus 2. And so the answer is, well, it's 0 when t equals 2. But I need to put 2 there and check, well, what happened to the left, what happened to the right. Yeah, so if I plug in a number less than 2, that's like 1, I will get a negative times a negative, right? I'm plugging in 1 right here. I would get, 1 minus 2 is negative 1 times 1 minus 2 is negative 1. I would get a positive number. And then if I plug in a number right of 2, right, like 3, if I plug in a 3 up here, I get 3 minus 2 is 1, 3 minus 2 is 1. They're both positive. Positive times a positive is positive. So what I see is it's always positive, except for at 2 where it was 0, right? The velocity was 0 at that spot. So the answer here is B, because it was always positive. It was always moving to the right, except at t equals 2 when it was stopped. Okay. The minimum value of the speed is what? So this one we're going to use our graphing calculator to help us a little bit because we haven't talked a whole lot about maxes and mins. So basically what we're going to do is we're going to find the velocity function, because speed is the absolute value of velocity. We're going to find our we're going to graph our velocity function, and then we will see where it's a minimum. So our velocity function was this guy, right? 3t squared, so 3t squared x squared minus 12x plus 12. We're going to look at our graph and figure out, well, where is the speed a minimum? And so you're just trying to find the minimum of this, and the minimum here occurs at t equals 2 again, right? If you see, the bottom point on this guy is at 2. Okay, that's that. Acceleration is positive when what? So now I need to find the acceleration, which is the derivative of the velocity, right? So we're saying, oh, acceleration equals 6t minus 12. And if I'm trying to find when it's positive, I first need to find when it's 0. So I set it equal to 0. 6t minus 12 equals 0. Therefore, t equals 2 again. But we need to do that same thing, right? Plug in 2, or put 2 there and figure out what happens to the acceleration left of 2. So plug in a number left of 2. If I plug in like 1, I'm going to have 6 minus 12, which is going to give me a negative. If I plug in a number right of 2, like 3, I'm going to have 18 minus 12, which is a positive. So left of 2, it's negative, and after 2, it's positive. So the acceleration is positive when t is greater than 2, right? Right of 2 is all t values greater than 2, like 3, 4, 5. The speed of the particle is decreasing when, right? So I already did all the things I need to do this. I just had to figure out when is the speed decreasing, right? So notice we already have this for velocity up here. Let's go ahead and draw these on top of each other, right? We could do this. We have our time, which is, here's t less than 2, here's t greater than 2, here's my velocity, here's my acceleration. I know that my velocity is always positive. My acceleration is negative on this one and positive on this one. And decreasing speeds are when the signs are different, right? Because if they are both at the same side, then the acceleration is pushing the velocity to be even faster. But if they're opposite, then the acceleration is pushing against the velocity. And so that, where I highlighted, is where that is decreasing, which is t is less than 2. So it's A on this one. Okay, let's go over to these other multiple choice ones over here. A particle moves along a horizontal line, right? We have a line like this, and you have a little particle, you know, so on the line it's like a number line, right? 1, 2, 3, you have -1, -2, and there's this little particle, and he's going this way and that way, and it's moving back and forth, right? And we're given this position function that tells me where it is after a certain amount of time. The first question is, when is the particle at rest? Right? When is it at rest? At rest means it's not moving. Not moving means the velocity is 0. So let's find the velocity, which is s prime of t, which is the same as v of t. And we're going to get 4t to the third minus 12t squared plus, 24t. Erase 4t to the minus 18t squared plus 24t. We want to know, when is the velocity equal to 0? So when is this equal to 0? Let's go ahead and factor some things out. Let's factor out 2t. This would be 2t squared minus 9t plus 12. And our job now would be to try to factor this, and you might try a bunch of things and realize that it's not working. I can't find anything that factors. So a good idea is to go ahead and check, are there any solutions to that equation? Right, solutions are x-intercepts, right, because it's equal to 0. And if you graph just that piece, you'll see this, which has no solutions, right? So this piece right here has no solutions. Right, the only solution is going to come from this piece, right, which 2t equals 0, so t equals 0, right? That's the only t value in here that gives me a solution. And so that is the answer to this one. When t is 0, the particle is stopped, right? At t equals 0, the velocity is 0. For 23, we want to know when the velocity is increasing. So we got to do some of this work that we did before. Let's go like this, since we're going to have to do this anyway. Here's time, and so for velocity, let's put 0 here, and then there's times before 0 and after 0, and we want to see for my velocity, right? Before 0, is my velocity positive or negative? So I'm going to plug in a number before 0, like a -1, right? If I plug in -1, this piece here will be negative, and this piece will be positive, and so the answer is the velocity will be negative, right? Just check by plugging in the number up into that other piece, and you'll get a negative number. After 0, I'm going to plug in a positive number, like 1, and I would get a positive times a positive number, right? If I plug in like 1, I would get 2 minus 9 plus 12, which is a positive. Okay, but velocity is not the only thing I have to look at for increasing. I have to also look at acceleration. Acceleration is, for this function, 12t squared minus 36t plus 24. And we need to go ahead and set it equal to 0. Let's factor out a 12 to make our factoring lives easier. And then we can see that this inside piece, I could divide both sides by 12. This inside piece will be t minus 2, t minus 1. And so the answers are, the velocity is 0 when t equals 2 and t equals 1. So we're going to go on our number line here, we're going to put 1 here and 2 here. We know that our velocity is always positive in all of these things, right? Now we have to check our acceleration. So before 0, our velocity, if I plug in like negative numbers, I will get a negative times a negative, which will be positive. Between 0 and 1, the same thing happens, it will be positive. After 1, this piece becomes positive and this piece is negative, and so we have a negative. And then after 2, they're both positive again. So the velocity is increasing when the velocity, so because this is velocity, velocity will increase when the velocity is positive and the acceleration is positive, right? And so that happens here, and then after 2 as well. Velocity is increasing. Oh, you know what? There. So I actually overcomplicated this one a little bit. The velocity is increasing is simply when the acceleration is greater than 0, because it's just increasing. It's not about, sorry, we're looking at this one up here. The velocity is increasing when the acceleration is greater than 0. So the acceleration is greater than 0 happens here and here, right? When t is less than 1 and when t is greater than 2, right? Those are when the accelerations are greater than 0. So when t is less than 1 or t is greater than 2, so d in this case. This is just like the slope thing, right? The acceleration is the rate of change of the velocity. So the rate of change of velocity is positive when the velocity is increasing. So, but we did do all this work for a reason, because on 24, it's asking about the speed. When is the speed increasing? And the speed is increasing when we're looking at this thing when the signs are the same. So that would happen between 0 and 1, right? The signs are the same between 0 and 1 and after 2. So there you go, A, between 0 and 1 and after 2. 25, we said we were going to skip that one. 20 for now, and then 26 is a new one. The particle moves according to this law, and the number of times it reverses direction is what, right? So let's reverse direction means it has to stop. It's going forward, it stops, it goes backwards, or the vice versa, right? It's going backwards, it stops, and it goes forward. So we need to look at velocity. So we take the derivative, you know, 5t to the 4th plus 20t to the 3rd. And we're going to set it equal to 0, because in order to reverse directions, you must first stop. And then we're going to factor stuff. So let's factor out a 5t to the 3rd, and we'll be left with t plus 12. And basically 0 product property, set each one equal to 0. So 5t to the 3rd equals 0, and t plus 12 equals 0. You'll get t equals 0 and t equals negative 12. What we need to check is, does it actually, this is where the velocity is 0. We need to check that it actually reverses direction, right? So we make a little chart, we put in 0, and let's put 0 here and negative 12 there. And then we check different numbers, plug in a number left of negative 12, like negative 13. If I plug in negative 13 here, it's going to be negative and negative. Both will be negative, which makes a positive. If I plug in a number between 0 and negative 12, like negative 6, then this piece right here would be positive, and the other piece would still be negative. And so it would be a positive times a negative, which is a negative. And then I plug in a number after 0, like 2, 3, 4, it's going to be a positive times a negative.